ladies and gentlemen, dear colleagues. It's a great pleasure for me to be here in Belgrade, and it's also a great pleasure for me to have the possibility to present you the current state of groundwater management in Austria. So what's the content of my presentation? First, I will give you some facts about the general conditions in Austria, about the natural conditions, about the administrative levels, and about some facts about water. Then I will give you an overview about groundwater in Austria, about groundwater protection and groundwater monitoring. I think we heard yesterday and today some things about it, and it will give you, I hope so, a little bit more information. Then I will inform you about the groundwater status assessment in Austria, about the quality and chemical groundwater assessment, about the methodologies, about the results, and then about information about the National Water Management Plan, which are going enacted, and at the end a summarize. So what's about the general conditions? As we heard in several presentations yesterday, it had to be into account the fundamentals, the geographical fundamentals, also then other conditions to get the right properties, to get the right tailor-made solutions. And so Austria is a little country with about 40,000 square kilometers and 80.2 million inhabitants. It's a mountainous country in the east and plains in the east. And the altitude, even the country is so small, is between 100 meters and 3,800 meters above sea level. Only approximately a fifth of the land is arable land and was used intensive agriculture. So Austria is also part of 3 international river basin districts. The major part is the Danube basin, and we also have some parts for the Rhine and for the Elbe. And so the Austrian territory drains into 2 seas, the Black Sea, and also to the North Sea. What's about the level of governance? Also we heard a little bit of it. Austria is a federal republic and is divided into 9 provinces, federal states, and they are subdivided into 84 regional districts for administration. The local competencies are guaranteed in the districts as well as in municipalities. And the provinces are not only administrative divisions, they also have certain legislative power and independent from the federal government. And the provinces are also responsible for the implementation of most parts of the federal water legislation. So what's about management? Basic facts about the water balance. The precipitation, the mean annual precipitation is about 1,100 millimeters. As we heard yesterday, it's in the Alps 3,000 millimeters, in the east, in the plains, only 500 millimeters. But in sum, Austria enjoys a most favorable situation, a hydrological situation. The precipitation and inflow from bordering countries results in a fresh water volume of 120 billion cubic meters per year, and of which 84 billion cubic meters are available. But the water consumption are only 3% of the available, about 2.6 billion cubic meters per year. Water supply, in contrast to many other countries where drinking water is produced by multi-stage chemical treatment of surface water, Austria used mainly groundwater resources which are available on a large natural quality. We also heard in several presentations. It's first and foremost the result of the high standard of groundwater protection in Austria. From the population, about 87% are provided by central water supply plants, and roughly 1 million people in Austria are supported by private wells or springs. Current sources for the Austrian drinking water are spring water 50% and groundwater 50%. So surface water is only used in exceptional cases on a very small scale. The daily consumption of drink water is about 135 liters per inhabitant. Take the industry and the business into account, it raises up to 230 liters per inhabitant. So, what's it about groundwater protection? The main instrument for groundwater management is the Austrian Water Act, which regulates the use and the protection of water resources, the groundwater resources in Austria. The Water Act guarantee requires the water uses must be permitted. It's very important for the quantitative aspects. And in order to avoid pollution and to ensure the future use of drinking water purpose, groundwater resources have to be protected as strict as possible. Hence, the Austrian Water Act entails the principle of an overall protection of groundwater, the whole territory of Austria. And drinking water standards represent the basics for these quality targets in groundwater. With the aim of protecting water supply plants, the Austrian Water Act also requires the establishment of protection areas. At the present, about 200 larger protecting areas and a large number of small, nearly 2,000 protection zones for smaller water supply plants have been installed in Austria, and the area comprises a total of about 10% of Austrian territory. So you see the importance of groundwater for drinking water supply for Austria. Within the frame of the Austrian Water Act, a number of ordinances concerned with groundwater management has been enacted. The most important ordinance for groundwater quality is the, in March 2010, enacted Ordinance on Environmental Objectives Chemistry Groundwater. This regulation stipulates in particular requirements of quality threshold values and established the methodology for the chemical status assessment and the criteria for a good chemical status. Groundwater monitoring has a long tradition in Austria. The protection and the management of groundwater would not be possible without the knowledge of relevant data. Therefore, a comprehensive water monitoring system was established in Austria quite some time before the VFD introduced such requirements. Presently, the monitoring network for groundwater quantity comprises over 3,000 groundwater level gauges, 579 groundwater temperature gauge, and more than 100 spring gauges. The systematic quantitative groundwater monitoring started in the early 1940s. The Austrian program for monitoring groundwater quality started in 1992. It covers also the entire national territory with a intensive network of sampling sites. The sampling site network for groundwater currently comprises over 2,000 groundwater sampling sites and over 230 springs. And this monitoring network was developed in the last years. Yet I come to the next point for the groundwater status assessment. The background for the status assessment was the status quo analysis and the results of the risk analysis. The status quo analysis comprises a description and classification of water bodies, a review of the impacts of human activities on the waters, including a first assessment of the compliance with the quantity and quality objectives. And first, based on the result of the status quo and the risk assessment, the existing quantitative and qualitative monitoring networks was reviewed and have been optimized. To implement the status assessment, it was in addition necessary to establish further legal foundations, especially the mentioned Ordinance on Environmental Objectives, chemistry groundwater was elaborated. And based on the results of the monitoring in the years 2003 to 2008, the quantitative and qualitative status assessment was accomplished with the development methodologies. So what about the chemical status? The methodology for chemical status was in fact to compare the measured value of a parameter with a threshold value, and the good status was defined when less than 15% of the monitoring sites are endangered is a monitoring site, and then when the arithmetic mean of a measure parameter from 3 years is higher than the belonging national threshold value. We taken also into account the trend, and the good status is defined with no increasing trend with an X point exceeds 83% of the threshold values in a period of 6 years. As I mentioned, 2003 to 2008. What's the results? The result of the chemical status assessment revealed the most groundwater bodies are in a good chemical status. We have delineated in Austria about, I think, approximately 140 groundwater bodies. And from these, only 3 groundwater bodies are not in a good chemical status due to nitrate. But because of the natural conditions in Austria, the concentrations of nitrate cannot be reduced to the threshold value of 45 milligrams per liter to 2015 in these 3 groundwater bodies. Because with respect to the agriculture use, the deadline for achieving a good status will be exceeded to 2027. The extension is necessary in account to the long resistance time of groundwater. It's often more than 30 years. And for this reason, a reduced input of nitrate only very slowly and sustainable affect a reduction in groundwater. So what's about the quantitative status? Here, similar, the methodology was a comparison between the measured groundwater level and a defined groundwater level, and it was defined at a characteristic low groundwater level. And when 60% of the monitoring sites, the average groundwater level is over this characteristic level, it was a good status. It's for the single groundwater bodies where we have enough data to do this this methodology. And for the groups of groundwater bodies, we have another methodology. We compare the abstraction with the estimated available groundwater resource, and there we define that the good status will be when the abstraction is not more than 90% of the estimated available groundwater resource. The actual results of our investigations indicate that all single groundwater bodies and all group of groundwater bodies are in a good status. So, as I mentioned, the assessment for qualitative and chemistry status assessment was only for shallow groundwater bodies. We have in Austria also delineate deep groundwater bodies, about 9, and this was not possible to transfer the methodologies for shallow groundwater bodies unlimited to deep groundwater bodies. And currently, there exists only an inconsistent data set about the groundwater level and the groundwater quality in these deep groundwater bodies, and therefore it was not possible to work out a general status assessment method for these groundwater bodies. And hence, the identification of the quantitative and also the chemical status had to be based on expert judgment. This was done by experts on a regional level, which brought in the knowledge about the deep groundwater bodies in their field of responsibility. And the results of this expert judgment was that all deep groundwater bodies in a good chemical and quantitative status. So, what's about the National Water Management Plan, the actual? The first National Water Management Plan was elaborated in a long-term process over many years. In the year 2009, the draft of the plan was subject to a public consultation, and altogether approximately 400 comments to this were arrived. They all were account to the further steps on the elaboration, and the final version of the plan was published in March, end of March 2010. The legal implementation was done with the ordinance to the National Water Management Plan, and this ordinance was also enacted end of March 2010. In the ordinance, the environmental objectives as well as the public policy in water management laid down in the National Water Management Plan were declared mandatory. Henceforth, the legal requirements are also available to implement the program of measures. The National Water Management Plan gives an overview over the analysis of the characteristics of the groundwater bodies, the impacts of human activities on groundwater, the economic analysis of water use, and monitoring. And it contains a detailed summary of the results of the status assessment, the environmental objectives on groundwater, and the results and the program of measures.